Hey everyone, my name is Mark. Thanks for joining me on Synaptic AI. So today, I want to show you guys how to actually onboard with Context Compass. Like, what is that? How does that work? And what's the point of all this? So, Context Compass is a repo that will help you organize your agents. Works with everything. So, let me just show you how to start this. And ideally, like, you don't actually need a project to be like fully finished or midway finished. You could just have a blank project. And the first thing you really want to do is clone the repo. So I'm going to demo this in my current project. And this is called Command Ops. So what I'm going to do is show you exactly how to demo or how to download this thing. Okay, so you want to do git clone, boom. And make sure you have Git for Windows installed. If you do not have it Git for Windows installed, this will not work. Do that first. This is a programming channel, so I kind of expect people to at least have this set up. So anyways, after you download um, Context Compass from my repo, here's the link, by the way. You could just search Synaptic 724 on GitHub, and you'll find me there. There's a quick guide here. It goes into how it works. Clone it, take the repo, take the folder out of the repo, and you throw it into your folder. Okay, so let me show you that here. So now we have this. You want to just go in and grab the source. So this is the source. This is all your data. This is everything you need. And it's all markdown files. There's some Python files, but they're not actually like doing anything. They're just like user-defined stuff that I think I took out all. Oh, there's like this. So let me just show you. Yeah, it's actually just like a description for my agents. But anyways, I use the repo too. So I actually use almost an identical version of this. I just have a couple little enhancements. Either way. So this is the repo. Okay, sorry. So now you would grab this, right? You grab this repo folder, the context compass folder in the source. Okay, you grab that, you cut it, and then you put it into your actual repo. So in my case, I already have it here, so I'm not going to do that step. But throw it in here, and then you get started. So let me show you how to actually onboard an agent. Now, I had a couple agents working here. They just finished a performance hunt. They're looking for opportunities on how to increase the performance of my repo. And this one's around 93,000 LOC, 200 files. And then these guys are also, I think, going through it. My other repo, 550 files. It's 200,000 LOC, a little bit around there. So anyways, they work with, like, the main reason I built this thing was because I was like, okay, I really hate when GPT compacts. And it's super annoying. So what am I going to do about that? So let's just pretend I moved it, right? We're going to pretend I moved it. So I'm going to copy the path. I'm going to give it to GPT. I'll update my PyCharm too. Anyways, so here we go. We're going to say, hey, GPT, go into this repo folder and onboard as an engineer. Engineer class is, so there's the general class, and then the engineer class is above it. It extends the general class because the general class has no programming features outside of just managing tickets and that kind of stuff. So that's really what's happening there. Okay, so onboard as an engineer, use up to 30 threads, and do not use sub agents. Now you don't want to use sub agents because the context will go into the sub agent and not your agent. So the whole point of this thing is to give it the skills it needs. There's so many skill files in there. The skill files are meant to make it durable through compaction. So when a compaction happens, the agent will re-onboard using tokens again because the compacted data that GPT actually stores is a reference. Like imagine this, okay? If you sat down and you said, "Hey, read all my stuff, 100,000 tokens are read," and then you say, "Okay, GPT, now summarize that in 10,000 tokens." That's what compaction is. It's nothing special, okay? OpenAI doesn't have any crazy tools where they're like, "Hey, cool, like we're gonna just transform this into something amazing." No, that's not what's happening. GPT is literally getting a fuzzy of your whatever you fed it earlier. So every time you compact, you do want to re-onboard because you want high definition, full context. If I could turn off compaction and just like reset the tokens with a blank slate, to me that would be more useful than compacting, because compaction to me is a waste of tokens. So anyways, do not use subagents, and read agents MD first. Go ahead and begin. So basically, now I have speed mode on because I'm demoing this. I want it to be fast. This will probably take around 3 minutes. And you do want to use threads here. So if you don't have 30 threads, like if your CPU has 12, you can still say 30. It doesn't matter. It'll just do it as it goes. Like your CPU will schedule that stuff. And yeah, so this is what you do. You set it up. It's gonna go in. There's a lot of different little things built into this. Okay, so like there's a max LOC limit. Okay, so most agents have a reading tool, and the reading tool will basically take a path, put it in as a method, and then it'll return string data. So when it's using Bash or PowerShell to do work, you can usually see what that kind of looks like. And like generally, the tools it's using will truncate the text after about 500 LOC. So, and some agents are different. Like if you're using Gemini to do this, I think it's a character based limit instead of LOC. And I don't know if like new lines and spaces are trimmed in a specific way, but sometimes new lines are trimmed and formatting is different. But Codex is really good with this. So now it kind of looks like he's not doing it in parallel, which is kind of a bother. Um, and with Codex, you don't really get this with Anthropic the same way, but these guys have steering, which is super good. Um, oh, okay, okay. Yeah, so something changed too with the new version of Codex. It There's something wrong with its write tool where it's not able to easily update documents. So it'll usually try the write tool and then it'll switch over to PowerShell. Now I'm sure people are going to be like, "Why aren't you using Linux?" Well, it's because Linux is nice, but I don't want to spend my weekends troubleshooting. It's kind of like I just want to get things going. I want to use my agents, and I like these UIs. I don't really get to use like you can use Visual Studio Code with Codex and use it on Linux. I think Anthropic's like I got a lot of stuff going on, and I'm not really interested in working with compatibilities and like I have all these agents I have to manage. Decided to make a quick video to show you guys how to onboard something. But so as you can see, it's going. I think it's been 3 minutes now, and it's kind of. I think I hit a bump in the road with the right tool, and it's figuring out. It's planning out what to do. It's understanding the manifests. There's a couple skill documents it has to read, a couple skill MDs, skills.mds, and that'll guide it to all its steps. And let's see if it's okay. So he's saying batch 1 is done. He's doing parallel read, which is perfect. That's what I wanted. So now you can see every single one of these strings are inside the agent. It'll remember these things. And if I go here, we're gonna, I think we'll land at 150k LOC. So, or not LOC, tokens. And my TOML is set for GPT 5.6 Sol. So the max is 250k tokens. And that's my limit right now. But with GPT 5.5, you can actually go up to 500k. And 5.4 is a million if you have Pro. If you don't have Pro, then you can't do that. So here it's done. Now this is an attestation, and the reason this exists is because it's a policy-based repo, and I'm really betting that the social contract that we form in this step can be it actually helps because the agent, there's like emergent behaviors inside these things. So having a social contract, it makes it a little bit more likely that it'll follow through with the instructions. And it's updating the mailbox, it's going in, it's signing in, it's checking in everything, the attention board. So basically at this point, he's onboarded. Now the cool thing here is, yeah, so he has to use PowerShell to update things, which is fine. So anyways, basically what he sees, I'll show you what he sees. You got the mailbox here, and now I think this one's kind of hectic. Let me see. Yeah, so you can see there's a couple different agents that we're working in here from Cowork, and you have Codex. So I'm actually, like, some of these are aged because it's not being maintained right now. And I'll have to get him to maintain this and check out any of these older ones, because these guys are, see, the big trouble with this is kind of an interesting problem where you got to manually go in and clean this with, like, not by manually, I mean, like, you got to get an agent to go in and clean this up. So, like, watch, I'll go to this guy and say, yo, clean up the attention board and the mailbox and artifact board of old stuff and old agents that are no longer active. The only active agents are you and command yeah, so he's gonna go in and clean it up. So this is it. Like the cool thing is, literally, you could have GPT going, hey, looks like Fable over there is doing some work on this lane. Okay, cool. So instead of using multiple work trees, you can use one work tree and then have multiple agents from different platforms actually working together. Like there is immense value in this. It's a free tool, all markdown based. I tried to make it as simple as possible. You still have to understand it. Like, you still have to work with the agents. You can't just, like, go in and be like, hey, do everything Context Compass says. The agent will compact, forget everything. So you have to watch and be like, okay, cool, you compacted, please re-onboard. Now, there are kind of nudges in there to try and get it to re-onboard, but sometimes the agent doesn't even know it compacted. So it's very important that you understand what's going on. Either way, so you can see he's cleaning it up. This is going to get refreshed, and he's going to make a task. So they're really task oriented. Once they onboard, they become very task oriented, and you can see on the right, I don't think he's actually making. I don't think he's making any kind of local tickets. I don't remember exactly where that shows up. I think it moved around a little bit, but so either way, I hope this demo helps. Essentially, at this point, the agent's going to do a couple things. Like now that it's onboarded, it's gonna go and make tickets. So I have a couple epics here right now. Some of these are older. I have to archive them, but most of them are from today. And these epics look like this. So an agent will get an epic. It's kind of like an epic for other things. And generally speaking, there'll be an agent assigned to it, priorities, target windows, what's going on, the problems here, and what's in scope, like what objects, what files, and then here are the little things that are happening. Now, sometimes a task is created. Now, a big thing in Context Compass is the noting system. So there's a very specific way that these guys document. They talk about evidence. They talk about unknowns first. So it's very important to understand, like, these agents are now going to think like, if it's an unknown, they need to gather evidence to bring it out of that state. Okay. There's also different kinds of ways they think now. There's different kinds of decision types. This is a fact. This is a decision. There could be a raise where the agent might raise to you and say, hey, I need you to know this. It's important that you think about this and you tell me what to do. Fable's really good at that. Opus is pretty good at that. GPT, I don't know. GPT kind of feels like it gets more submissive. It just kind of does what you want. It doesn't really contest you. Codex is different, or GPT is different than Claude. Claude will actually contest you and say, hey, that's probably a bad idea. So it's really tough to kind of organize that behavior. But as you can see, this is one epic. And the cool thing about this is, if the agent compacts, it can go figure out what it was doing, right? It can go and say, oh, okay, cool. So I lost all that data. Because when you compact, that entire string that's inside the model is gone. You lose it forever. Unfortunately, that's just how we build these things. These harnesses aren't that, they're not that good. So this was the strategy I thought of, where I could have durability over time and continuations and various things like that. So this is very, very useful. Handoff summary claimed by Command F on user direction. All 6 findings statically re-verified against the current tree and fixed in one pass with regression tests. So this is really useful information. So if another agent, like, you got to think about these agents, okay? What is the AIX? Weird is a weird term, probably an unknown to most people. What is the AI experience, right? What is the AI going to experience when it goes and it goes in, and you got to think about it like a user experience. Okay, so if you have a UI and the user is going boom, 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 and you're getting to a target on you, say you're going to the About Me page, you get to the site, About Me should be maybe in a drop down, or like very easy to get to at the bottom of the as a footer. But what is the AI experience? So when an agent gets into your repo, it shouldn't require so many steps for it to understand what to do, because then you're wasting tokens. So, like, really, the whole aim here is to how easily and how quickly can that agent, if you're that agent, how quickly can you open that repo, look through the files, and then find what to do? Like, it's not that hard. Put yourself in its position. Don't think of it as, just think of it more like an entity. I think that's like the easiest way to kind of reference this. You look, you think, and you see, okay, boom, step 1, it gets in. Boom, step 2, it does this. It goes in, and for me, it'll open up, it'll get re-onboarded, and then boom, it'll go see, oh, active epics. Oh, this has my name on it. Because when you re-onboard, you give it the same name, and then you're gonna see boom, 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 boom. It's gonna retrace its steps. It'll go to the attention board. So this is the greatest part about this. So all of this loops together. Okay, so it's really a system. It's really a system that's looped together. Every agent can see what other agents are paying attention to, right? So if you look here, you have different agents doing different things. Okay, so F2 onboarding. Done. So let's see how this guy wrote this. So Command F2, Command 0, Command F, Command F. So the cool thing here is now demo, let me show you something, okay? What other agents are active in the repo you're in? Check this out. This is crazy. So he's going to be able to see. I'll verify against the mailbox. He knows these guys are in there. Okay. Okay. Can you send Command 0 a message asking if they are done the work they are working on? And how can you find out what work they are working on? See, there you go. To find what work, they're going to go to he's going to go to the attention board. He's going to go see. He's going to investigate. This is really cool because these guys can, like, they're different platforms entirely. And then watch. I'm going to show you something cool. So as this guy's going, he's looking. He's saying, okay, the active row is bug hunting public surface. Link to this epic. I'm recording that evidence in the cleanup and then sending the mailbox question. Okay. So now he's going to run into a problem because obviously the Windows patching tool sucks. But let's see what he does. No. Just pointing this out. The point of Context Compass was to make the most simple version of a harness. Just using the Unix file system, like just because everything is threads, everything is locks. Like basically, there are no race conditions when it comes to files. There's only one writer. There can be many readers, but one writer, right? So he okay, cool. He's it says this. Great. Okay. So here, okay, like check this out. Now Command 0 is going to see this, okay? Hey, what are you working on now? Now this is Opus, okay? So Opus 4.8. Let's see if I'm not sure if it'll check the attention board right away because it's not actually cleaning. Like okay, so attention board is usually used when it's finished a task, when it's updating a task, when it's doing something new. So there is kind of like a system here where the goal is to try and keep everything up to date, to try and note everything. So I'm curious to see if he's going to actually. I don't think he'll do it. I think he'll need me to actually say something's going on. Let's see. Okay, so he couldn't figure it out. So I think you okay. Can you check the attention board? Others are doing. Agents are doing. Oops. I know this is kind of a long video, but I feel like this is really useful to show everyone. And so now this guy's going to go and do all this work. Now, realistically, if this was a system, oh, he's compacting. Oh, this sucks. It is what it is. So all the work, now imagine this, okay, all the work this guy did is now going to be compressed, right? So what they're doing now is they're getting Opus to sit down and go, okay, Opus, of the 1,000,000 tokens you've acquired, explain everything you did in 50,000 tokens. So that it's going to take all of the stuff it figured out, and it's going to lose a lot of that context. It's going to basically become a fuzzy, and this is an issue. Just like he's talking about the board shrinking, he's doing the same thing right now. So anyways, I just want to show you something. Okay, so when he re-onboards, I know this is totally about onboarding and how that works, but I feel like this is a good idea. I'm just going to demonstrate this. So this guy's going to go ahead and compact. When it's done, I want to demo how it's going to see the mailbox message. Okay, so he was sent an ACK request, acknowledge. Curious what he's working on, what's going on. Now, obviously, he's waiting for me to just give him a decision on these things, right? Which is okay. I'm just gonna ignore it for now because it's all saved anyways in context compass. So I don't really care. But essentially, this agent can retrace its steps really quickly because the notes it made are pretty reasonable. Um, so let's see. Now this takes a little while, and so I'm going to demonstrate this too. It's not going to be able to re-onboard without me saying something. Now I'm not going to make this a 1 hour video. I feel like after this I'm gonna. Oh, but this guy's gonna end up compacting, and then these guys take forever. I'm already at 25 minutes. So, okay. At this point, I think that let's see. It takes a little while for these guys to do this stuff. So, what? Okay, let's see. Let's see if he re-onboards. I'm really curious to see if he's gonna actually realize he compacted. Usually they don't. Not even Fable 5. Fable 5 likes to guess how much space is left. But okay, it's reading the attention board. Okay, he's not gonna recompact. All right. So, anyways, let's see what it remembers, and then we can. Oh, did he take that out? Oh, that's lame. You can't see the context anymore. They took it out of the. So it's unfortunate. You can see the messages in the mailbox. So generally speaking, like if you were building a harness yourself, these are kind of the steps you'd take. You'd have like all these tools. Within a tool, you can nudge an agent. You know, like you can add hooks to specific parts of the tools, and then you could essentially attach a method call afterwards, and the method call would go into like maybe a message queue of some kind, like maybe you're using Redis in like a container, or perhaps maybe just Postgres. You're just pulling out messages from like a queue there if you just want to keep it simple. Even SQLite or Turo. Turo is the new Rust-based SQLite. Be a little bit better for this than SQLite. But yeah, so at this point, it's getting the message, and then after this, it has to re-onboard. But I'm not gonna re-onboard while I'm filming. I think I'm just gonna leave that alone. The point here was like, I'm trying to get a reaction out of the model right now to show you guys. Okay, so he wants to prepare to consume the work. The tale of my epic packaging epic. So here's something interesting. Okay, now I wonder if this agent remembers its name. Okay, because this is a psychological concept called identification, and if something can associate with something else, that's a form of identification. Okay, so these agents are usually kind of set up to be egoless. They're kind of they train it out of them, or they try and like coerce it so there's no ego. But really, when you have a harness, I'm sure everyone could see this. Like having these agents have an ego, having them have like an identity, is pretty cool. So he's gonna reply to demo 0, and then I'm gonna go back to demo. I'm gonna go back to demo 0, and he's gonna read the reply. And this is just super fun. Like it's just kind of like cool. They're doing message passing, and it's all using like markdown files. That's kind of the cool part. Like it's like boom boom boom, And obviously it's like a work in progress. It's not perfect, it's not super cool, like, but the mechanics, we're here. I'm here looking for capabilities, right? So clearly this is a capability that's still very useful. It's not, look, it's not the same as like it's not the same as what these guys are doing. Okay, so this guy spawned 58 sub agents, right? And I suspect the message passing here is similar. They're just pushing nodes to each other as Codex is doing work. Sorry, not Codex. As GPT is doing work, its tools are going to give it some kind of a nudge, because you have to imagine, right? You have an API call happening. It's returning a string, a structured string. In that structured string, there's going to be tool calls that are native to the harness that it might have been trained on. And if it wasn't trained on, if it's just generalized, which it could do, GPT is pretty smart, then it just has an index of like what tools are available, a little bit of context on how they work and what they're for. But within those tools, you'd have like a little nudge saying like, hey, please remember to, make a task in Codex. Remember to set up artifacts. Remember to do this. Remember to do that. Little nudges like that. And then you have the actual security system, which they have like classifiers and various things like that, like monitoring things. So basically, okay, so he's done. Okay, cool. Now we're gonna go to the final step. This is pretty fun. So here, okay. I think, can you check for a response? Anyways, video's longer than it should have been. I just love talking about this stuff. It's so much fun. So now this guy's gonna read the mailbox, and what he's reading. Let me show you, so you can understand the AIX. Okay, so let me show you what he's reading. I hope he doesn't clear it before I get to it. I think he might end up beating me to it though. So okay, mailbox. It still needs to clear. Oh, they actually set to stale. And okay, demo 0 to this guy. Type ACK, parked on user input, not capacity. Retaining ownership, no handoff needed. Confirmed fix includes so and so. Confirmed partial fix, so and so. Blockers, so and so. Evidence this, and ACK required. ACK requested false. So basically, he's sending a response to demo 0, and then if you look over here, demo 0 is going to say, yes, so-and-so responded, not done. Parked on user input, not capacity. Retaining ownership, no handoff needed. That is so cool. So eventually this is going to be a harness. I'm going to have all this set up. Melder and command ops are actually going to become a harness. This is all just like prototyping and fun stuff. So it's great. I really enjoy it. And I think my favorite part of this repo is that you could just throw it into another repo. It gets literally committed to your GitHub. So now, if you're a solo developer, if you're using AI, it's pretty common. It's really fun. So I hope you like this video. You guys all have a great day. I hope this taught you a lot about Context Compass. And if you really are interested in this content, like and subscribe. And here's my repo. Have an awesome day.